If we have a look at another neutron-rich radioisotope, one of which is quite interesting to us, is cobalt-60. Now, the stable isotope of cobalt is actually 59, cobalt-59. So it's got one less neutron than cobalt-60. So cobalt-60 is another one of those neutron-rich radioisotopes. So once again, one of the neutrons is going to transform into a proton and an electron. Okay, and that's going to give us a new element once the electron's expelled from the nucleus of element number 28, still with a mass of 60, and that is corresponding to the element of nickel. We write in that we've got the electrons being expelled. Now, when this nickel is produced in the reaction, okay, in the nuclear reaction, it's actually got a very high energy level, the nucleus, okay? It's in an excited state. So what occurs, as well as the beta, as well as the electron being emitted from the nucleus, which is our beta radiation, beta particle, okay, this is a form of beta decay as well, obviously. We also get some gamma rays emitted from the nucleus, okay? And those gamma rays are measured in electron volts. And those that are emitted from the nickel nucleus are quite high in energy. So that allows the nickel nucleus to go from an excited state back to what we would call a ground state of energy. Now, cobalt-60 is really handy, okay? Because it emits the gamma, we would call that the source, okay? So any particular radioisotope, we call it a source of radioactivity, okay? Now, industrially, cobalt-60 is used for a wide variety of things. One of the main uses is to detect faults in metal structures. So what actually occurs is that we put the cobalt-60 source, okay, on one side of a particular piece of metal, okay. So let's say we've got some form of metal structure, okay, and the cobalt-60 source is going to be directed at this metal structure. So what we're going to do is we're going to avoid any radiation penetrating any other areas by insulating it, if you like, with a thick wall of lead. And so that's going to ensure that whatever radiation is emitted is going to go straight through the metal structure. And in this particular instance, the gamma will be able to penetrate through. And on the other side, we're going to have what we call a gamma camera, which is present. And that's going to detect the proportion of gamma that's able to go through the metal structure. Obviously, an increased gamma intensity measured by the camera will correspond with a structural defect. And that's cobalt-60.